Hey everybody, this is chapter 4, section 3. Title is Patterns and Nonlinear Functions. Starts on page 246. In section 2 we were talking about linear functions. Like I said in class, a lot of the stuff that we do in this section will be related to the stuff from section 2. This is about nonlinear functions. In section 2 there were 3 ways to know if a function was linear or not. A function is linear if the graph is a straight line, if the table has x values that change by the same amount and y values that change by the same amount, that makes it linear. And if you have ordered pairs that don't have the same x value. All 3 of those tell you that you have a linear function. There are 2 ways to tell if you have a non-linear function. If the graph is not a straight line, like it's a curve or it has a bend in it someplace, or if the y values, x values and y values don't change by the same amount. And we're going to use both of those in this section. Example 1, graph the function represented by the table below. Is it linear or nonlinear? Before we graph it, I just want to take a look at the table to figure out if it's going to be linear or nonlinear. 0 to 1, 1 to 2, 2 to 3, and 3 to 4. All those x values change by the same amount. They change by 1 each time. The y values also change by 1 each time. So if the x value does the same thing and the y values do the same thing, that's telling me that it's going to be linear. So if I have a linear function, what am I expecting to see in my graph? Well, I'm expecting to see a straight line then. Let me change this real quick. Okay, let's graph these points. So I've got 0, 12 is an ordered pair. 1, 13 is an ordered pair. 2, 14 is an ordered pair. 3, 15 is an ordered pair from my table, and 4, 16 is an ordered pair. Those make a straight line. That's what I was expecting to see because straight line means linear. So both of those things agree. Example 1b, same type of problem. Let's look at the table first. 0 to 3 is plus 3, plus 3, plus 3, plus 3, plus 3. The x values are all doing the same thing. What about the y values? Plus 0, because it doesn't change. Plus 0, plus 0. Minus 0.1, minus 0.1. Okay? Those y values do not all do the same thing, so I'm expecting it to be nonlinear. Okay? Nonlinear, I'm not expecting this to be a straight line. So I graph the points, 0, 7.5, 3, 7.5, 6, 7.5, 9, 7.5, 12 and 7.4, so that's a little lower, 15 and 7.3, so that's a little lower again. So this graph, not a straight line. So I was right, it's nonlinear. Okay? Practice problem for you. There's a table, there's a graph. Check to see with the table if it's going to be linear or nonlinear, and then double check it with the graph. Same thing for practice problem number 2. We're going to skipping problem number 2. In the last section, there's 2 ways to find a relationship using words. And I mentioned when we were talking in class that was the part that a lot of people make mistakes on. We had the guess and check way and we had the pattern way. Both of those work for linear functions, but if you're trying to find the relationship of something that's nonlinear, only the guess and check way is going to work, and we'll review that in this lesson as well. In the last section, they asked us to find an equation that works for the relationship. Okay, they said find an equation. In this section, instead of using the word equation, they use the word rule. So they're going to ask us to find a rule.
Faculty meeting in the library in 4 minutes.
Rules for nonlinear functions usually have exponents in them. Nonlinear means that there's going to be an exponent somewhere. For example, you can have something like y equals x squared. The 2 is an exponent. You can have something like y equals 2x to the third power. The 3 is an exponent. You could have something like y equals x squared minus 1. These would be examples of nonlinear functions, okay, because of those exponents. Here's what one would look like. What is a rule for the function represented by the ordered pairs? Now, first we have to figure out if it's linear or nonlinear. Look at the y values. 1, 4, 9, 16, 25. Is each one of those changing by the same amount? Well, 1 to 4, that means plus 3. 4 to 9, that means plus 5. 5 to 16 is plus 7. 16 to 25 is plus 9. Those aren't all changing by the same amount, so I know it's going to be nonlinear. It's nonlinear because the y values go up by different amounts. So I know I have to use the guess and check method. Okay? I also know it's nonlinear, so it's going to tell me that there's going to have to be an exponent somewhere in my rule. So I'm going to pick one of these ordered pairs. Let's try to get from 3 to 9. How do I get from 3 to 9? Well, what if I try y equals x to the third? So if I plug my x in, 3 to the third is 27. Is that what I was trying to get? No, I was trying to get 9. So that doesn't work. Now let's try x squared. If I do 3 squared, I get 9. Okay? It works for that one. Does it work for another one? 4 squared is 16, so it works for that. 5 squared is 25. Over here, 1 squared is 1. 2 squared is 4. Okay, so squared works for the entire table, for all of my lists of ordered pairs, which means that my rule is y equals x squared, because I took the x value and squared it and got my y value, which is my answer. Another example of something like that. Write a rule that represents this function. Look at my y values again. 0, 4, 16, 36, 64. Are each one of those going up by the same amount each time? No, it's not, which means that it's going to be nonlinear. I'm going to need an exponent of some sort. Now, I want you to know, I'm never going to give you any exponents except squared or cubed, so no exponents other than a 2 or a 3. I'm not going to give you something like x to the 4th or x to the 5th. Okay? So that should help you limit what you're going to have to guess and check with. So with this one, let's try y equals x squared. Okay? If I do 0 squared, I get 0. Okay, that one works. If I do 1 squared, I get 1. Okay, that doesn't work, but let's keep going. 2 squared is 4. 3 squared is 9. 4 squared is 16. Okay? And it says, look for a pattern. Is there a way that I can get from the answers that I just put down here in red to my y values? Okay, let's look at 2 and 16. How can I get from this 4 that I already got to a 16? Well, multiply by 4. That'll give me 16. What if I multiply 9 times 4? Ooh, it gives me 36. What if I do 16 times 4? That's equal to 64. 1 times 4 is 4. 0 times 4 is 0. So I've done two things to my x value. I've squared it. I've squared all of my x values. And I've multiplied all of them by 4. So those are going to be the two parts that are in my rule. Squared and multiplying by 4. So my rule is y equals 4x squared. I took my x and I squared it, and I also multiplied by 4. So that's 4x squared. That's one of the trickier ones that we'll do. Another practice problem here, same type of idea. Another practice problem in number 4. In this one, they give you a table. They tell you that the classmate was wrong. So what I want you to do is tell me what the correct rule would be. Okay? Figure out what the rule is for that table and tell me what the correct rule would be. Another spot here for questions or comments if you have any, and we can go through those next time we have class.